So we have quadratics past paper questions, and this is a selection of a few questions that will demonstrate some of those key things that we talked about last week. So our first one, find the set of values of k for which the equation 2x squared plus 3kx plus k equals 0 has distinct real roots. And there is your trigger. Your trigger is those last three words. Distinct real roots. And what that should trigger is your discriminant. Whenever you have information about the roots, then you are generally heading to working with the discriminant. And if we think about it nicely, well, we've got two variables here. We've got k and x. So there is no way that we would be able to solve this for either of them. If we want to solve for two variables, then we would need two equations, and here we only have one. But they want values of k. However, our discriminant, remember, enables us to work with just the coefficients. So we would be effectively getting rid of our x's and working just with our k's. So let's have a look at how it all pulls together. We have 2x squared plus 3kx plus k equals 0. So remember, the coefficient of x squared is your a, your coefficient of x is your b, and your coefficient of nothing, your constant term, is your c. Note that I've included the signs there because your signs are included, they're part of the coefficient. So if we want distinct and real roots, we want that b squared minus 4ac, that piece out of that quadratic formula, to give us two different answers, in which case it's going to have to be bigger than 0. So b squared is 3k squared minus 4, a is 2, and c is k. And this will be greater than 0. And now we've actually sort of calmed ourselves right down, because now we're working only with one variable, only with k, and the question says find a set of values, and we have an inequality, so we are working towards a set of values. Remember, always substitute with brackets, as this is what keeps everything safe. So 3k all squared gives us 9k squared minus 2 times 4 times k, 8k, greater than 0. And the breaks go on completely, because we said squared here. We have a quadratic, and we have an inequality. So whenever we bump into a quadratic inequality, now we're going to have to insert that piece of working. So for critical values, okay, we're giving a reason as to why we're going to get rid of this inequality, because we can't solve a quadratic with an inequality. It doesn't work. The whole functionality behind solving that quadratic is that you have multiplication and 0, because anything times 0 equals 0. So 9k squared minus 8k now equals 0, because we've given that information as to why we're doing this. Now we can very simply factorize, no numbers in common, so it's just a k. 9k minus 8 equals 0. And we can solve this. We get k equals 0, or k equals 8 over 9. So this is now AS, is not IG anymore. So you don't have to show that k equals 0, or 9k minus 8 equals 0, 9k equals 8, k equals 8 over 9. You can skip all of that, okay? But you must have quadratic equals 0. You must have factorized equals 0, and you must have two answers. So this is your minimum set of working for solving a quadratic. Quadratic equals 0, factorized form equals 0, two answers. Remember, once we've got our critical values, we're going to relate this. Hyperquadratic greater than 0. So mini sketch, our values are 0 and 8 over 9. Hyperquadratic bigger than 0, so we want these two zones. So our final answer then goes back to an inequality, and we have k is less than 0, representing the left-hand side, or k is greater than 8/9, representing the right-hand side. And as it's just a greater than in the question, it is just a less than and a greater than in the answer. There's no or equals to. Because at or equals to, we don't have distinct real roots. We have a shared real root, the different form of our discriminant. So there you have it. Your set of values of k, for which the equation 2x squared plus 3kx plus k equals 0 has distinct real roots, is k is less than 0 or k is greater than 8/9. What are the triggers in the next question? Express 4x squared minus 12x in the form 2x plus a all squared plus b. We've got one x in a bracket with a number all squared plus a b. This here is completed square form. This question is actually that really funky completed square format where we've got that extra number in here because this one here is a square number. Okay, so we're happy with that one. We're going to complete the square. And then part 2, hence or otherwise, find the set of values of x satisfying 4x squared minus 12x greater than 7. See them there? Quadratic inequality. So this one here is a quadratic inequality. So you should get the idea now that you're going to bump into this over and over and over again. Okay, so it's well worth getting that technique sorted. Okay, so let's get some answering going for this question. Expressing in completed square form. Now what we're going to do is we're going to do it the slightly long way around so that we use the same method that's in the lessons. We're going to pull out that coefficient of x squared, then put him back in as an exponent. So, looking at part 1 first, we have 4x squared minus 3x. Okay, now we're going to complete the square on this piece. So, x plus a half b, so minus 3/2, all squared, minus a quarter, b squared, minus 3 times minus 3 is 9, plus c, well there is none, so that's it. So now we can bring in that 4, x minus 3/2, all squared minus 9. We're nearly there, but we need to bring that 4 in. So a reminder quickly of your exponent laws. Remember that if you have ab to the m, this is equal to a to the m, b to the m. Now the really cool thing is that usually we use this in this direction. Exponent laws work in both directions, so we can also use it in this direction. Why is that very helpful in this particular question? Well, because 4 is 2 squared, x minus 3/2 squared minus 9. So we have the same exponent. We can use our law back to front, and that means then we can do our multiplication. So we would have 2x minus 3 all squared minus 9. And we have used our laws and we have got ourselves into the exact format that they said that we wanted to be in. So we have completed the square. Let's have a look at part 2. They say hence or otherwise find the set of values of x. So 4x squared minus 12x minus 7 greater than 0. Because remember, you want to always relate your quadratic to 0. So I'm not a fan of working with solving equations in completed square format. Nothing wrong with it. If you want to do for it, go for it. I like this way around. Okay, so quadratic. Happy quadratic, greater than 0. We relate it to 0, so we're now ready for our next step. For critical values, let them know what's coming. We would have 4x squared minus 12x minus 7 equals 0. Now, yes, factorize, not equations, factorize. Sorry, not formulas, factorizing. Formula is that last resort, that backup. Okay, so 4x squared, well, it could be a 1 and a 4, a 4 and a 1, or a 2 and a 2. We don't know, but that 7 is prime, so it has to be a 7 and a 1. So now we think about, we're going to make a 12, we've got a 4. 4 times 7, way too high. 4 plus 7, not there yet. However, 2 times 7 is 14. And if we take away 2 from 14, we get 12. Luckily, we have unlike signs. The bigger one wants to be negative in order to get the minus 12x. So 14 is bigger than 2, so minus and plus. So x is going to equal 7 over 2, or x is going to equal minus a half. So you can factorize them even when they don't look quite so friendly. And it is a lot quicker and a lot less open to error than using your quadratic formula. Quadratic formula is your last result. Last resort. Factorizing is where you want to go for. So another plea. Please make sure that you get yourself sorted and happy with quadratic factorization. One line equals 0, one line factorized, one line, two answers. Next comes mini sketch. So minus a half and 7 over 2, and we're looking for happy quadratic greater than 0. So again, we have two zones. So our final answer comes down to x is less than minus a half, or x is greater than 7 over 2. And when it comes to AS Maths, bear in mind that you are working with fractions more often than decimals. We want to keep that level of accuracy. Also, we generally work with improper fractions, our top-heavy fractions. We don't tend to put them into mixed number forms. Okay, when we're working with coordinate geometry and things leading on from there, then a mixed number is going to just drive us nuts and be complicated and unwieldy to deal with. So we rather leave it as a improper fraction. 7 over 2 is absolutely fine. Let's have a look at the next question. Talking about coordinate geometry, this one is extending a little bit into coordinate geometry now. Okay, but it's still very much the techniques that we learn using our quadratics. So coordinates of a point of intersection, this here is simultaneous equations. So very much a technique from when we're working with quadratics. Okay, so we have a line and we have a curve, and we need to solve them simultaneously. Remember, we must always think first. So let's get them out there. Our line is y plus 2x equals 11, and our curve is xy equals 12. Now, the thing about simultaneous equations is that we always want to keep it as simple as possible. So if we were to make x a subject, we'd be dealing with all sorts of fractions. Whereas this y here is sitting on his own. So if we make him the subject on his own, we can just substitute into the next one. So this becomes y equals 11 minus 2x. Now we can go and substitute into xy. So we would have x, instead of y, we now have 11 minus 2x, and that equals 12. So 11x minus 2x squared equals 12. Let's rather work with a happy quadratic, get that x squared term positive before we go and factorize it. So 0 equals 2x squared minus 11x plus 12. Okay, so maybe the other thing to note is that we're not showing plus 2x squared on both sides. We're not showing minus 11x on both sides. because we're starting to work now more in our head. We've done a lot of equations by the time we've got to this stage. So we should be comfortable with working between the two sides of this equation without showing everything. If you're still in a place where you need to show everything, otherwise you make mistakes, show everything. Okay, but work towards that concept of these are now one of my basic skills and I need to be comfortable with them. And I need to be working at a pace at which I don't make silly mistakes. So if you need to work a little bit slower, do so. If you find yourself speeding up and rushing and making too many mistakes, you've got to make a plan to do lots and lots and lots of practice so that you can reduce those mistakes. Right, another quadratic. Chances are we can factorize again. Look, here we have our prime number as our coefficient of x squared. So 0 equals, this can only go 2x and x. So now we've got a 12 and we're working for an 11. 12 would not work. That's not going to give us any combination to get an 11. 6 and a 2, again, we're working with a whole lot of even numbers, so we're not going to get towards that 11. So if we think about odd numbers involved in 12, well, there's a 3 and a 4. Okay, right. So 2 times 4, that would give us an 8, with a 3, would give us an 11. So we have a 4 and we have a 3. Like signs, both negative. So we have x equals 3 over 2, and we have x equals 4. But remember here, we want coordinates of point of intersection, and we're solving simultaneously. So we're not just solving for x, we are solving for x and y. So at x equals 3 over 2, y is going to equal 11 minus 2 times 3 over 2. We have this rearranged format here at the beginning that says y equals. So that's the easiest one then to go and substitute into in order to calculate our y. So y equals 11 minus 3, which is 8. We're back at 8 again. Okay, so our first point of intersection we have there. Then at x equals 4, y equals 11 minus 2 times 4. So y equals 11 minus 8 again gives us 3. So they asked us specifically for coordinates of intersection. So in this case, we're going to give our answers as coordinates. You're always going to pay very careful attention to your question. So they just ask you to solve for x and y. Then you'll just solve for x and y like we have done here. If they ask you for coordinates, you must give them as coordinates. So we can then conclude that intersections at 3 over 2, 8, and 4, 3. Our 2 points of intersection between the given line and the curve, just as they asked us for. Our last question for today is quite a similar one, but we're leading on to now building in another element that we looked at earlier. So we have find a set of values of k. So this now should be triggering some kind of inequality for which the line meets the curve. This now is going to trigger some sort of simultaneous equations. Like we've just done. At 2 distinct points, that also sounds familiar. Remember we said this is going to trigger our discriminant. So this is why this question was picked for this lesson. Last week, I talked about the fact that we're going to combine all sorts of different things all into one question. This one's only worth 5 marks. And here we've got 3 different techniques. We've got a simultaneous equations, we've got an inequality, and we've got a discriminant, all working together to solve one question. So we have y equals 2x minus k, and we have y equals x squared plus kx minus 2. Now, in order to use a discriminant for intersections, we first have to build an equation of intersection. So that's where our simultaneous equations come in. So for equation of intersection, we've got to combine those two. And to combine two equations, we need to put them together simultaneously. Both of these are y equals, so it makes our life so much easier. We have 2x minus k equals x squared plus kx minus 2. Simple and straightforward, because if y equals this and y equals that, then this equals that. Let's get everybody on the same side with a happy x squared because it's easier to deal with. X squared plus kx minus 2x minus 2 plus k. Okay, but remember, if we're heading towards a discriminant, we want to see that obvious a, b, and c, those coefficients of the x squared and the x term. So 0 equals x squared plus k minus 2x. Then let's just put these the other way around, k minus 2. So now we have x squared term, x term, constant term, nice and clear. Okay, so you may get to the point where you can do all of this as one and you can see it and you can pull it out and it's all nice and straightforward. But while you're practicing here at the beginning with these more complicated discriminant questions, then make sure you're showing these steps nicely and clearly so you can follow on. Okay, so we're now ready to use that discriminant. So for values of k. So we're using subheadings here to break up our working and to help us track through what it is we're doing and why. So it's also easier for our examiner to mark and easier for us to check our answers when we're finished and we're coming back. Why did I do this? Ah, that's why I did it. Okay, so b squared. K minus 2 squared. B squared minus 4ac. Now, two distinct points greater than 0. So opening up, k minus 2 times k minus 2, k squared minus 4k plus 4 minus 4k plus 8 greater than 0. So when you're expanding, don't make silly mistakes, okay? Because that's not something that we're testing here. We're just assuming that you can expand brackets. If you need to do it slowly, but avoid any silly mistakes. Okay, combining like terms. K squared minus 4k minus 4k minus 8k plus 4 plus 8 plus 12 greater than 0. And you see it, quadratic inequality. What comes next? For critical values. So now we have k squared minus 8k plus 12 equals 0. We've justified. And no surprises, we're going to factorize again. So I suppose that's another topic that's included. So we've got the 3 we mentioned, plus quadratic factorization. Okay, so factors of 12, which add to give us 8. That is going to be very simply a 6 and a 2. We have like signs, both negative. So k equals 6 and k equals 2. Once we've got our values for the critical values, it comes the mini sketch, 2 and 6. We want happy quadratic greater than 0. So 2 zones. So therefore, our final answer is k is less than 2 or k is greater than 6. One inequality for each of the zones. If we were looking for where our quadratic is less than 0, we would have taken the space in between and we would have had only one inequality, just with 2 endpoints. So always pay very careful attention to what it is your question is specifically asking you so that you can get the right areas for your answer. So let's just go back up here and add in that 4th element of quadratic life that we also did. Quadratic factorization. So we've now got 4 elements of that quadratic story, all within one question. And that's why it's so important to have each of these elements secure and sorted, and you know what's going on, so that when you bump into them as you're working through a question, you can pull in whichever one it is that you need to use.